This is Tiger Chemists! Have you ever tried cooking a good tasting meal but ended up having a hard time to chew it? If yes, the pressure cooker will be of great help. But do you ever wonder how pressure cooker works? Are you curious how your favorite beef becomes tender and soft? Sounds interesting. Let's learn something new today. Today's episode will tackle how pressure cooker applies scientific concepts. The mechanism of the pressure cooker depends on two main factors, pressure and steam. This is what the pressure cooker looks like. Familiar? Chances are, your mom probably owns one. Pressure cookers are commonly used to cook liquid or steam-based recipes, which resembles the finished effect of long braising in a short period of time. Keep watching to understand how these pressure cookers do their magic. Let's go! A pressure cooker is sealed by a cover and a rubber sealant to prevent the unintentional escape of the steam inside it. 1. The water inside the pressure cooker evaporates and turns into steam. And 2. The abundance of steam increases the pressure inside the pot. Due to the increased amount of pressure, two major processes occur that make pressure cookers stand out. First, the boiling point of water is raised. Normally, the boiling point of water is limited to 100 degrees Celsius, and the temperature at which the food is cooked is bounded to 100 degrees Celsius as well. However, since the pressure and therefore temperature is increased due to the steam, the cooking temperature breaks the 100 degrees Celsius boundary. Second, the increased pressure also forces liquid into the food. Since liquid is a good conductor of heat, the food cooks faster. This process also promotes meat to tenderize quicker and also provides a moist and juicy finish. Now, do you know that you can apply the gas laws your chemistry professor taught you? Here's how it works. Gay-Lussac's law states that if a given amount of gas is held at a constant volume, the temperature is directly proportional to the pressure. This law can be applied to the pressure cooker. Pressure cookers also preserve the nutrients of your food. The nutrient-rich steam condenses and stays inside the pot, which prevents nutrients from being lost in the air. We can also derive a formula from the Gay-Lussac's law, which is P1 divided by T1 is equals to P2 divided by T2. P1 represents the initial pressure, while T1 stands for the initial temperature. On the other hand, P2 is the final pressure, and T2 is the final temperature. The standard unit for the temperature is Kelvin, while atmospheric pressure is the standard unit for the pressure. Now that we have learned these things, why not apply it in our daily life? Let's see how we can use the Gay-Lussac's law in cooking our food. Your mom wants to cook pork belly for your lunch. She uses the pressure cooker, and it has a pressure of 1.5 atmospheric pressure and a temperature of 313 Kelvin prior to being subjected to heat. While your mother is cooking the pork belly, the pressure becomes 3 atmospheric pressure. Now the question is, what must be the temperature inside the pressure cooker while cooking the food? Pause this video if you want to solve for the answer alone. Now, as we all know, the formula for the Gay-Lussac law is P1 divided by T1 is equals to P2 divided by T2. In the given problem, we are given the initial temperature, which is 313 Kelvin, and the initial pressure of 1.5 atmospheric pressure. The final pressure, which is 3 atmospheric pressure, is already stated. We are then basically asked for the final temperature. To start our solution, first, we must derive a formula for the final temperature by using the Gay-Lussac's formula. That gives us T2 is equals to P2 times T1 all over P1. Then, we will replace the formula with the given values. By calculating these values, we have 626 Kelvin as the final temperature inside the pressure cooker. Indeed, when the pressure increases, the temperature increases as well. Let's move on to another situation. You are tasked to look after the beef your mom is cooking. The pressure cooker has a temperature of 300 Kelvin since it is subjected to heat. Prior to being subjected to heat, the pressure cooker had a temperature of 150 Kelvin and the pressure of 1520 torr. What is the pressure while the pressure cooker is put above the heat? Pause this video if you want to solve for the answer alone. In this situation, the given are the initial temperature, which is 150 Kelvin, and the initial pressure, which is 1520 torr, and the final temperature, which is 300 Kelvin. We will now find out what is the value of the final pressure. From the Gay-Lussac's law, we derive the formula for the final pressure, which gives us P2 is equals to P1 times T2 all over T1. Note that for pressure, atmospheric pressure is the standard unit. Thus, conversion is needed in this situation. 1 atmospheric pressure is equals to 760 torr. Thus, 1520 torr should be multiplied to 1 atmospheric pressure divided by 760 torr in order to cancel the unit torr. After that, you can now calculate it. The result is 2 atmospheric pressure. Going back to the formula, let's replace the formula with the given. Finally, the final pressure is equals to 4 atmospheric pressure. It's amazing how our lessons can be used in our everyday lives, isn't it? Now, not only are you ready to cook with your family, but you can also show your chemistry skills. We hope that you learned something new today. Thank you for watching and stay tuned for our next video. This is Tiger Chemists. Until next time!